All right. Hello, hello. Last one of a three part, I guess, video series. Okay. Whatever. All right. Fighting angles. Okay. Um, this is where we left off in part two. And so we looked at reference angles and how to find the trig functions of those reference angles. Um, and we use those reference angles to find the six trig functions of angles that are not acute. Okay, so we use so as soon as you're an angle that's more than 90 degrees, right, then you're going to be using reference angles unless it doesn't say uh, find exact value, then you can go ahead and use your calculator. Okay, so here in this third part, we are going to look at how to solve for the angles. Okay, so take notes. We are still in 3.1. Solving for angles. We've done this before using the inverse trig functions. But those were always for acute angles. It always said, oh, find the acute angle such that tangent theta equals this or that, right? It always said find the acute angle. But now they're not acute. They're not acute. They're gorgeous. Okay. All right. So let's recall inverse. Okay, so hold on a second. It wasn't working there. Okay, how come it's not working? Just a second. I think my mouse is competing with my stylus again. Okay, so recall inverse trig functions. Find. All right, what is going on here? Is it because I made that terrible joke and so now nothing is working? Okay, find. Okay, so recall that inverse trig functions find angles. Um, okay, so for example, uh, in previous chapters, you were given something like, okay, tangent theta equals 1, find the acute angle. Ah, bummer. Okay. Okay. Let's let's see. Let's see what happens if I do that. All right. This is all the old stuff. It's probably because I'm running out of memory or something. Okay. Tangent theta equals 1. Okay. So let me move my mouse. And you were asked to find the acute angle theta, right? And so in the past, we just simply said, okay, well, theta equals tangent inverse of 1, right? And then we punched that into our calculator and we got some acute angle. Okay, so now the angles are not acute. Okay, so angles are not acute. And so we're going to need more clues. Okay, so more clues are needed. Okay, so what are those clues? Quadrants. Okay, so here we're going to need to know what quadrant the angle lies in. Okay, so let's take a look. Let's find theta. Find theta to the nearest degree. That word says degree. If sine theta equals negative 0.5592. Okay. And so that's not going to be enough. Okay. Because now we have a bunch of angles that could have that answer, negative 0.5592. All right. So we need some clues. So here, and theta terminates in quadrant 3. But even that's not enough because we have coterminal angles, right? So let's put this restriction here with theta between 0 and 360. Okay, so we won't go beyond 360. So we won't get like the 540s or the 410s or anything like that. Okay, so with theta between 0 and 360. Okay, but not including 360. Notice that. Okay, because 360 and 0 are the same. Okay, so find theta to the nearest degree if sine theta equals negative 0.5592 and theta terminates in quadrant 3. Okay, so let's just kind of draw that. So here is 0, 90, 180, 270, and we know it terminates in here. Okay, so when we use the inverse function, what we end up getting is actually the reference angle. Okay, so this here is going to be what we get when we use the inverse trig function. Okay, so theta hat will equal sine inverse. And what we're going to do here is we will always enter a positive number here. Okay, so even though up here, let me circle it. So even though this here is negative, we will always enter the positive. That way we get the positive reference angle. Okay, so we will get sine inverse of positive 0.5592. And when we punch that into our calculator, we get, and we round it off to the nearest degree, it's going to be 34 degrees. Okay, that's our reference angle. Okay, so if we are trying to find this angle, and we know now that this is 34 degrees, then here our actual theta is going to be 180 plus the 34, right? We can visually see that. And so we get 214 degrees. Okay. So again, I like to draw so that I can see what to do with this reference angle. Do I have to subtract it? Do I have to add it? And who am I adding it to? Who am I subtracting it from? Okay, so I like to draw this so that I can see what's actually happening. Okay, so I know it's in quadrant 3, so I just drew this angle terminating here in quadrant 3. I took the sine inverse of positive 0.5592. I got 34 degrees, actually some decimal, but we have to round to the nearest degree. And so I know what the reference angle is. And if I know the reference angle, then I can find the actual non-acute angle. Okay? So that's why when we said up here, angle, now the angles are not acute, so more clues are needed. So we need to know the quadrant. And it tells us theta terminates in quadrant 3. Okay? All right, let's take a look at another one. All right, find theta to the nearest tenth. To the nearest tenth of a degree if tangent theta equals negative, another negative there, negative 0.8541. And we need to know the quadrant, right? So, and theta terminates in quadrant 4. And of course, we'll put the extra restriction so we don't have to worry about coterminal angles. So we'll also say, okay, and it's also somewhere between 0 and 360. All right, so extra little restriction there, which makes it a little easier for us. Okay, so let's go ahead and draw this. 0, 90, 180, 270. Okay, where are we? Quadrant 4. So we terminate in quadrant 4. Our angle is somewhere between 0 and 360, so no negative angles. So we can't say, oh, it's this little angle. Nope, that's a negative angle. And it says here that it has to be greater than or equal to 0. Okay, so no negative angles, which means it's this really big angle here. Okay, so we are going to set it up similar to the previous problem. Okay, so our reference angle is going to be tangent inverse of, again, we're going to enter the positive number, not the negative. Okay, so this is going to be tangent inverse. So this, instead of saying negative 0.8541, we are going to enter the positive 0.8541. And that will give me, we want nearest tenth of a degree. So if you punch that into your calculator, you get 40.5 degrees. Okay, so that's what this reference angle is right here. This is 40.5. Okay, so to find the actual angle, we are going to do 360 degrees minus 40.5 degrees. And that will give us 319.5 degrees. Okay? Okay. Let's take a look at another one. Find theta. Let's do one with secant. They might not be as intuitive as the others, so let's try one of these. Find theta to the nearest degree to the nearest degree if secant theta equals 3.8637, and we need to know the quadrant, right? So, and theta terminates in quadrant 4. And let's say that theta is somewhere between 0 and 360. Okay, so no negative angles and nothing beyond 360, like 570 or something like that. Okay, so 0, 90, 180, 270. Okay, we are in quadrant 4. So another big angle here for theta. And it's this little angle here, theta prime or theta hat. Okay, so we have secant theta. Okay, so here's the thing. Secant theta equals 3.8637, right? Which means that cosine theta is the reciprocal, right? So cosine theta is 1 over 3.8637, right? So let's just work off of that, okay? Because we don't have a secant inverse button on our calculator. Okay, so this step is important, okay? All right, so now we can do our reference angle. Is going to be cosine inverse, again, of a positive number here. It turns out that it is already positive, so not a big deal. I was going to say if you forget. Okay, in this particular problem. All right, so cosine inverse of 1 over 3.8637. And we have to round to the nearest degree. So rounding off to the nearest degree, we get 75 degrees. Okay, so this little theta hat here is 75 degrees. So in order to find the actual theta, which is that big angle, non-acute, is we're going to do 360 minus that 75, and we get 285 degrees. Okay. I'm going to have you try one. Try this one. Let's make sure you understand it before you try some of the homework problems. Okay, so find theta to the nearest degree, to the nearest degree, if cotangent theta equals negative 1.6003, and we need to know the quadrant, right? So, and theta terminates in quadrant 2. And let's have that extra bonus restriction here, 0 degrees theta 360. Okay, so no negative angles and nothing more than 360. Okay. So let's draw this so we can make sense of it. 0, 90, 180, 270. We are in quadrant 2. So somewhere over here. So it's this angle that we want. This one here is our theta hat. Okay. So that's our theta hat. So theta hat is going to be, we're dealing with a cotangent. So let's work this out step by step. So cotangent theta is negative 1.6003, right? Then that means tangent theta, because we don't have a cotangent inverse button. So tangent theta is the reciprocal. So 1 over negative 1.6003. Okay? All right, so we're going to use tangent inverse. Tangent inverse of, again, a positive number. Okay, so when we enter this number over here, we are going to enter positive. So, okay, so tangent inverse of 1 over 1.6003. And it says to round to the nearest degree. So punching that in, nearest degree is 32 degrees. Okay, so this little theta hat right in here is 32 degrees. So if I want to find this actual theta here, I am going to do 180 minus 32 degrees, okay, which is 148. Okay, so there you have it. That is all of 3.1 reference angles. So if you have any questions, make sure you email me or text me. Make sure you are taking the attendance survey every single week. You will be dropped on the 4th absence. All right, until next time.